Hi, in this video we're going to look some more at numerically approximating this definite integral, and we're going to do trapezoidal rule again. So we're going to use trapezoids for our shape, but this time we're going to do it with a smaller partition so that we'll have more trapezoids. They'll be narrower. We should end up with a better approximation than we had in the last video. And we're going to do 6 trapezoids this time. So our n will be 6 trapezoids. So one of the things that will be important to know is how wide our trapezoids will be. So the width of our interval, of our whole interval, is 3, from 2 to -1. So 2 minus -1, or 2 plus 1 is 3. And then I want to divide that into 6 pieces. So 3/6 or 1/2 or 0.5 is going to be the width of our trapezoids here. We'll have 6 trapezoids and they'll be width 0.5. So up here on the picture, our first trapezoid will go from x equals -1 to x equals -0.5. I'm not going to draw them all here, but I'll just draw a couple here at the beginning. And then we'll use the y coordinates of the points on the curve to form one side of our trapezoid, and the other side will be down here on the x-axis, and we'll just be finding the area of that trapezoid. So that'll be our first one, and then our second trapezoid will go from -0.5 to 0, so same width, and we'll use the 2 points on the curve there. That one almost looks like a rectangle, but if you look at our numerical values, you see that they're not exactly the same height there. They're just pretty close. And so we'll use these values that are in the table here for our y values, our coordinates of our points. So, alright, so one thing that you need to do is either remember the area formula for a trapezoid or the formula for trapezoidal rule, which is in our textbook. Okay, so I've pasted here the formula for trapezoidal rule as it's typed in your textbook. And so we've got our delta x. We know that's going to be 0.5, and we're going to divide by 2. These y values that are here in this formula are going to be the y values that are here in my table. So my y0 would be my leftmost endpoint. That's going to be 1.74. My next y value is going to be 2.06. And you might remember we talked in the last video about why these 2's are here in this formula. It's because the two trapezoids, there are 2 trapezoids that have that side of height 2.06. All these ones in the middle, there are really 2 trapezoids next to each other that have that same side. Alright, so all these y values are the y values in my table. I'm going to be multiplying the middle ones all by 2, and then just adding on the 2 end ones, add that all up, and multiply by delta x over 2. Alright, so I'm going to organize my work here a little bit differently than I did last time. Sometimes students find this helpful just to make sure that they can do this without messing up typing things into their calculator, kind of doing it in steps instead of typing in that whole formula there. Alright, so I'm just going to use my chart that I have over here, and then in the chart I'm just going to multiply all of these y values that are in the middle by 2. So I'm kind of just using my chart as a way to organize my work here. And I'm going to go ahead and write what I get when I multiply those numbers by 2. So 2.06 times 2 is 4.12. 2 times 2 is 4. 1.06 times 2 is 2.12. Negative 0.26 times 2 is negative 0.52. Negative 1.29 times 2 is negative 2.58. Alright, and so I'll add all those up, and then I'll need to also remember to add the 1.74 and the negative 1.96, those 2 y values on the end. Sometimes I see students forget those, so one way to make sure you don't forget those is to just write times 1, which of course doesn't change it, but then you have all your values lined up over here that you're going to actually end up adding. Okay, so then all these values that I've got here, so what I've really done here is just kind of use my table to help organize the work for everything that's inside the parentheses here on that trapezoidal rule formula. So I want to add up all those numbers, and so you get out your calculator for that. So you should end up with 6.92 when you add up all those numbers. Alright, and then I'm going to go back over here to my formula, and I'm just going to go ahead and plug in my values to my formula. Our delta x, the width of each trapezoid, was 0.5 divided by 2, and then I've already calculated everything that I put a box around there. That was 6.92. I used my table to help me organize that. So go ahead and do this multiplication. If you want, you could divide 0.5 divided by 2. You get 0.25, and take that times 6.92, and you should get 1.73. All right, so here we used trapezoids, and we used narrower trapezoids than before. So really, between all of the approximations we've done for the same region, the same function, the same integral, this one really should be the most accurate that we've gotten so far from what we've done here. The trapezoidal rule in general is more accurate than using rectangles, and of course the narrower of the shapes you use, the more shapes, the narrower shapes you use, the better that approximation should be. Alright, so in the next video we'll look at using Simpson's rule for this same shape and talk about how we might expect to get an even better approximation using Simpson's rule.